Hi, my name is Brady, and this is a walkthrough of the CyberLens Challenge Lab on TryHackMe. This is a room that was created by Tyler Ramsby, who I know from the Hack Smarter Discord, so if you haven't jumped in there already, I would definitely recommend giving that a shot. This room is an OSCP-like lab, and so we're going to be conducting an OSCP prep style walkthrough, and what that means is basically we're not going to use Metasploit, even though, full disclosure, Metasploit is probably the easiest way to solve this room. But just for practice, we're going to be using manual exploits only. So without any further ado, let's go ahead and jump in here. So I've got the CyberLens room. I've got it all booted up. I can grab my IP address here, and I'm just going to throw it in my notes here, just in case we lose it. And we can go ahead. I'm going to start by exporting a variable. I'm going to call it IP and just save this here. You can also put this in your etc host file. I'm just not going to do it this time because I don't want to call it by host name every time. It's a little faster just to type IP when you're just working with one here. So we can do nmap IP, and that should come through pretty quickly here. Okay, so our results came through here. It looks like a pretty standard set of ports here for a Windows server. We've got HTTP running on port 80, and then we've also got RPC, SMB, and then RDP running down here. So what we can do is we can go ahead and do some default scripts and service version enumeration, which is what the SCV flag here does. And this is going to take just a little bit longer, so I'm going to go ahead and do a quick cut here. Okay, so our script just came through here, and the real information that we're looking for here is the service version here, and we see 2.4.57 for Apache. This is not something that's going to be exploitable in this case, but we can go ahead and check this out. And then we also have some more information here about some of our other services, but most importantly here, we just want to be checking out the web server in this case. So I'm going to go ahead and open up Burp Suite, since I already have that pre-staged here. I'm going to open up Burp's browser, since that's what I'm going to be wanting to work with for this web server. And then I'll put our IP address in here, and we can load this up. And I'll see if I can make this just a bit bigger. So here we have our Welcome to CyberLens homepage. And if we either click this or scroll down a little bit, we have this CyberLens image extractor. And this is basically a proprietary tool that will let you upload a file here, and then you can go ahead and extract the metadata from it. So what we can do is we can just make an arbitrary file here. So we'll echo test to test.txt. So we have something to put in there. And we can go ahead and choose a file, and we'll grab test.txt. And then this get metadata is what we're going to want to hit next, but I'm going to go ahead and turn intercept on here in Burp Suite. And then we'll go ahead and get metadata. What we can see here is that we get an options request for this /meta. And this host here tells us our host name, cyberlens.thm, but also interestingly, it gives us this high port 61777. So let's go ahead and check this out real quick. We can do our same nmap scv command, but I'm going to supply a port this time. Okay, and just a quick jump cut ahead here. You can see I actually ran this twice, but it didn't seem to work. Basically, what I was expecting here was the HTTP title, which shows us the server version. But you can see it's running here on Jetty 8.y.z snapshot. So this isn't actually useful for us. But if we go ahead and we open up this page, we can just say this IP and then 61777. It's going to tell us welcome to the Apache Tika 1.17 server. So this is actually what we want to be exploiting in this case. So if we go ahead and open up a new tab, and we can just call this Apache Tika 1.17, we can just do exploit. And let me make this just a tad bigger. So we can see when our first result here is from Rapid7, we can be pretty sure that there's going to be a Metasploit module for this exploit. And that is the case for us right now. We're not going to use it though, because we're doing an OSCP-like machine. So you can also see there's an article here from Rhino Security Labs, basically on the researcher that found this vulnerability, I believe. And this is a good read. I would definitely recommend checking this one out. We can also see if we scroll down just a bit, there are some GitHub exploits. And actually there is an exploit that I found from Rhino Security Labs. But I did have a slight issue with part of the exploit, so I made my own fork here. This may or may not be up at the time that you're watching this video, so if it's not, definitely check out Rhino Security Labs CVEs. But I'll have it linked down in the description, so you should be able to find it from there. So if we look here, basically this script is manipulating these headers, and through these headers, they're able to achieve command injection. So we can just grab this entire script here, and we'll make a new file. We'll call it exploit.py. I do need to supply a command here. So that's going to be this. Let me open this up just a bit more so we can see it. Okay. So we can see our usage here is basically Python 3, the script name, and then host, port, and command. So I'm just going to type this out because it's going to be a little bit big. It's going to be Python 3, and then it's going to be called exploit.py in our case. The host is going to be that IP variable that we set before. The port is going to be the 61777 that we found before. This is where Apache Tika is running. And then the command, I'm going to put this in double quotes because it's going to be a multi-argument command. And basically, we're just going to pass through a reverse shell command. So I can just open up revshells.com. Hard to type and record a video at the same time, I guess. And this is going to open up this reverse shell generator for us. So all we need to do here is supply our IP address, which in my case is 10.6.1.121. I'm going to go ahead and send this to port 443 just because this is unlikely to be firewalled off. And then we got to grab Windows, and then the payload that I'm going to use is this PowerShell number 3 base 64. I just find that this often works for web payloads, so I'm going to use this one. And then we can just come back to our notes and just dump this in here. And if we run this in our shell, we should hopefully be able to get something back to us. So I'm going to paste that in, but before I run it, I'm going to open up an RL wrapped netcat listener on port 443. And with this running, hopefully we should be able to run this command and get a shell back. Oh, and it looks like we didn't save our file. That's definitely important. So I'll go ahead and save that, and then we'll just rerun our command here. And now hopefully we should get a shell back. And it looks like we do. We can run who am I? And we see that we are this CyberLens user. If we run who am I priv, we can see that this user basically doesn't have any privileges. They just have change notify and increase working set. And then we can capture the user flag. I'm not going to show it for the purpose of this video, but we can just prove if we run like ICACLs, and then this flag is going to be at C users. And then I'm just going to copy this so I don't fat finger it. CyberLens. It's going to be on their desktop. And this one is called user.txt. So we can see that we do have full control over this file. So we would be able to read it and capture the flag. So I'm going to move this up just a little bit. This exploit is pretty stable, so if we needed to jump another shell out of this, we usually could. I'm just going to put that up there for safekeeping just in case we need it. But for privilege escalation on this one, I'm going to move over to my opt staging, and it looks like it's autofilling it for me, my Windows directory. And if I ls here, we're going to be using this powerup.ps1 script. This says some automated enumeration of privilege escalation vectors for us. So I'm just going to host this using Python 3 m http server 80. So this is going to host a server on port 80. And then we can just use a method of our choice to pull that down. Hang on to that for a little bit later. But I'm going to use PowerShell invoke web request HTTP, and then our IP address, which is 10.6.1.121. And then the file we want is this powerup.ps1. And then if we specify the out file, I'm just going to put this in C users public because we should be able to write there. And then I'll call it the same powerup.ps1. And if we go ahead and run this in our reverse shell over here, we should be able to see it come through on our web server. And we do. We see a 200, so we know that it was successful. We can come back to here. If we change back over to C users public, I really struggle to type when I'm talking. Okay, if we've got our powerup.ps1 file here. So what we can do is we can .load this file to load the module here, and then we can run the powerup function invoke all checks. And this is going to take just a second to run, so I'm going to go ahead and jump cut ahead to this one. Okay, so that finished running here, and we can see that what we have most interesting is the always install elevated registry key. So we can go ahead and double check this manually if we'd like. So we can do a reg query, and we can check on the H key local machine, and then we can do software. So that's all good. Policies. Wow, I'm struggling to type on this one. Microsoft, and this is going to be Windows installer. And we want to check the value. Always install elevated. Oh man, it is rough right now. Okay, so we see we do get this 1 value, so we know that this is turned on. And then we can do the same thing for the H key current user. Go ahead and just swap that out. And we get a 1 as well. So basically what this is telling us is that when Windows runs an installer file as any user, it's basically going to run with elevated privileges. So we can use that to run a malicious installer, which we'll create with MSF Venom here. Okay, so we can go ahead and create a payload with MSF Venom. I'm just going to type it over here. MSF Venom The payload we're going to want to use is Windows exec, and we can make our command equal to whatever we want. We're just going to reuse the shell command up here, but I'll put that in here for visibility in just a second. So the file type that we want is going to be MSI, which is the Windows installer file extension. And then our output file can be whatever we want. So we'll just call it revshell.msi. And then our command, we're just going to reuse this revshell payload just because we know that it already works. We don't need to get fancy with it. So basically, this will send us a reverse shell as an administrative user. And then we could be able to either establish persistence or act on the target however we'd like. If I grab all of this, I'm going to change back into my ops staging windows just since I'm already sharing that directory. And I'll go ahead and generate that payload right here. Okay, and a few seconds later, we can see that that came through. So here in my ops staging windows directory where this is already being shared, we can reuse our PowerShell command just to use the same thing and pull that down. So if we want to change this, we're just going to change it to revshell.msi, so we don't need power up here anymore. And it's going to go to the same directory and C users public. So come back to our reverse shell, run that command here. And it looks like it came through. We can double check here. We got a 200, so we're all good there. And then the way that we're going to run this is with MSI exec. So we've got a couple flags to use here. So we use MSI exec. We can use the quiet flag basically to let them know that we don't need to do any user interaction during the installation. We can run the QN flag, which basically just says that there's no user interface. And then we can run the I flag just to say normal installation. And then all we have to do is supply the name of our file, which is this revshell.msi. So I can just copy and paste that right back in there. I do want to use the full path in this case, just in case we get any funkiness with our installer here. So C users public revshell.msi, and we'll go ahead and run that. Before we do though, we need to go ahead and prep another reverse shell handler. So we'll do rlwrap, another netcat listener, lnvp 443, since we're still running to port 443. We've got that listening, and we'll go ahead and run our file here. And this should take just a second. It looks like it just ran, but it'll take just a second to come through here. Okay, and looks like it does. I probably won't cut that. It's just a few seconds just to show you that there is a bit of a wait there. So if we hit enter, we should get our prompt here, and we can say, who am I? And we are now NT Authority System. So we can go ahead and do the same thing. ICACLs on C, users. This time it'll be administrator, and it's on the desktop, and this file is called admin.txt. This is where the root flag would be, and you can see CyberLens administrator, the user that we're currently using, has full control, so we would be able to read that file and capture the root flag. So yeah, thanks to Tyler for creating this challenge, and I hope this was helpful for you. If you do have any questions or anything like that, feel free to leave a comment, and otherwise, I'll catch you in the next one.